Hello students, let us start with a new concept called as trigonometry. It is one of the very important branch of mathematics. It has got wide variety of applications in many fields. Trigonometry as one chapter we will learn. In this I am including the basic introduction to trigonometry and trigonometric identities. Along with that, we will also see the application of trigonometry basically related to heights and distances. The subject trigonometry is an important branch of mathematics. As I mentioned, the word trigonometry is a combination of three Greek words. It's a combination of three Greek words. Tri refers to three. Gon refers to sides. Metron refers to measurement. Thus, trigonometry is that branch of mathematics which deals with measurement of sides and the angles of the triangle. In trigonometry, we will basically consider the right-angled triangle. We define the ratios of pair of sides of right-angled triangle corresponding to an acute angle of the right-angled triangle. The ratio are called as trigonometric ratios. Let us go back to the basics. We have learned right-angled triangle. A right-angled triangle has got a right angle. By the definition, that means all the sides cannot be of the same length. A typical right-angled triangle is shown below. You can see here. Here you can observe there is right-angled measure mentioned at one of the vertex. This is a right angle. We mention it in this way. These two angles, they are acute angles. One of the right angle will be present in the right angle triangle and the other two angles are acute angles. Here one of the acute angle is named as theta. It should be pronounced like this, theta. With respect to this angle theta, the side which is adjacent will be adjacent side and the side which is opposite will be the opposite side. And we all have learned the longest side in a right angle triangle is hypotenuse. There are some important terms which are to be learned in right angle triangle. The right angle is indicated by the little box in the corner. The other angle that we usually know is indicated by some symbol. Here the symbol used is theta. The side opposite to the right angle of a right triangle is the longest side and is called as hypotenuse. The side opposite to theta is called the opposite side. The side next to theta, which is not hypotenuse, is called as adjacent side. Now let us start with the basic trigonometric ratios and their names. Let us consider a right angle triangle ABO as shown in the adjacent figure. Now with respect to the acute angle, angle AOB, which is mentioned here as theta, angle AOB, the adjacent side OA becomes hypotenuse and other adjacent side is OB. It becomes the base. and AB is a perpendicular. We call this as a base or adjacent side. And this perpendicular is the opposite side. We are going to define 6 basic trigonometric ratios. These are the ratio of the sides with respect to the angles. AB by OA is perpendicular by hypotenuse, or else it is opposite side by hypotenuse. It is named as sine of theta, or briefly it is written as sine theta. It is pronounced as sine theta, not as sin theta. It is pronounced as sine theta. OB by OA. OB is the base. OA is the hypotenuse. Base by hypotenuse, in other words, it is adjacent side by hypotenuse, is called cosine of theta. It is briefly mentioned as cos theta. Cosine of theta is briefly mentioned as cos theta. AB by OB is perpendicular by base, or else it is opposite side by adjacent side. It is defined as tangent of theta, and it is briefly mentioned as tan theta. The ratio OA by AB is hypotenuse by perpendicular. In other words, hypotenuse by opposite side, it is called cosecant of theta. It is briefly mentioned as cosec theta. OA by OB is hypotenuse by base. In other words, it is hypotenuse by adjacent side. It is called as secant of theta, and briefly it is mentioned as sec theta. And the last ratio, OA by AB, is base upon perpendicular. In other words, adjacent side upon opposite side. It is called as cotangent of theta, and briefly mentioned as cot theta. Make a note. The side opposite to angle under reference is taken as perpendicular, and the side adjacent to it, except the hypotenuse, is taken as base. All other ratios, these ratios are also pure numbers. Since it is a ratio, it has not got any units. It's like a fraction, 3 by 4, 4 by 3, like that. In a right-angled triangle OAB, in the previous figure OAB, angle BOA lies between 0 and 90 degree. That is, it is an acute angle. Theta is an acute angle, and also 6 trigonometric ratios which are defined, they are all positive. Each trigonometrical ratio is a real number. Let us learn a concept called as reciprocal relation of trigonometric ratio. Reciprocal relation of trigonometric ratio are explained here to represent the relationship between the 3 pairs of trigonometric ratios as well as their reciprocals. For that, I am considering this figure. In this figure, you can observe the adjacent side, perpendicular, hypotenuse are mentioned. The angle PMO is a right angle, it's 90 degree, and this angle MOP is theta, an acute angle. This theta value is between 0 and 90 degree. Sin theta is Pm upon OP. Cos theta is OM upon OP. Tan theta is Pm upon OM. Cosec theta is OP upon PM. Secant theta is OP upon OM. Cot theta is OM upon PM. Once again, I'll let you know this. We have sin theta, which is opposite by hypotenuse, in other words perpendicular by hypotenuse. Perpendicular is PM, hypotenuse is OP. Cos theta is adjacent by hypotenuse, in other words it is base by hypotenuse, it is OM upon OP. Tan theta is perpendicular by adjacent side, in other words opposite by adjacent. Cosec theta is OP by PM. You can observe these two ratios, sin theta and cosec theta. Can you observe and make out something here? If you observe properly, you will realize that sine of a angle theta is nothing but the reciprocal of cosec theta, or cosec theta is the reciprocal of sin theta. Now I want you to observe cos theta and secant theta. Cos theta is the reciprocal of secant theta, or secant theta is the reciprocal of cos theta. Tan theta is the reciprocal of cot theta, and the cot theta is the reciprocal of tan theta. These three trigonometric ratios will give three more trigonometric ratios. Further, I want you to observe sin theta is Pm by OP, cos theta is OM by OP. If you take the ratio of sin theta upon cos theta, we get Pm by OP divided by OM by OP. OP will get cancelled. Pm by OM is obtained. It's nothing but tan theta. So the result obtained is tangent of a theta is the ratio of sin theta upon cos theta. Very important, you must know this. We are going to make use of this concept, reciprocal relation, in solving few questions. Same way, if you take the ratio cos theta upon sin theta, we get OM by PM, it's nothing but cot theta. So the result obtained is cotangent of theta is cos theta upon sin theta. This is another important relation. How to remember these ratios? I'll give you a trick to remember to define the trigonometric ratios. This is a trick. The trick is you can remember this word SOHCAHTOA. What does this SOHCAHTOA refers to? These are the three basic trigonometric ratios. S refers to sin theta, O refers to opposite side, H refers to hypotenuse. So sine theta is defined as opposite side upon hypotenuse. C refers to cos theta, which is adjacent side upon hypotenuse. T refers to tan theta, which is opposite side upon adjacent side. When these three basic ratios are known to you, you can find the reciprocal. If you make this upside down, we get cosecant theta. Cosecant theta is hypotenuse by opposite. When we take the reciprocal here, we get secant theta, which is hypotenuse by adjacent. When we take the reciprocal of this, we get cot theta. It is defined as adjacent side upon opposite side. So you can make use of this trick if it is difficult for you to remember sin theta as opposite by hypotenuse, cos theta as adjacent by hypotenuse, and tan theta as opposite by adjacent. This trick would help you to remember all the 6 trigonometric ratios. We need to learn trigonometric ratios of some specific angles. From geometry, you are already familiar with construction of angle 30 degree, 45 degree, 60 degree and 90 degree. In this session, we will find the values of the trigonometric ratios for these angles and of course for angle 0 degree also. Let's start with the trigonometric ratios of 45 degree. For that, I'll consider a right angle triangle. When 45 degree is there, this angle is 45 degree, angle A. This remaining angle also will be 45 degree. What comes to your mind if two of the angles in a triangle are equal? It becomes an isosceles triangle. Yes. When it is an isosceles triangle, the side AB and the side BC will be equal to each other. In triangle ABC, right angled at B, if one of the angle is 45 degree, the other angle is also 45 degree. That is, angle A equal to angle C, which is 45 degree. As I mentioned, the side BC will become equal to the side AB because they are the sides opposite to equal angles. Suppose if I mention the side BC to be A units, the side AB also will be A units. In that case, using Pythagoras theorem, we can find the length of AC and it turns out to be A root 2 because A square plus A square is 2A square, which is AC square. So AC will be root of 2A square. AC will be root of 2A square. It is nothing but a root 2 multiplied to A. It is mentioned as A times root 2. When the sides are A and A times root 2, what happens to the trigonometric ratio? Let's analyze. I'm taking again right angle triangle. Using the definition, let me define the angles here. Suppose angle A is considered this as the reference. Sine of this angle 45 degree, sine 45 degree will be the side opposite to the angle 45 degree, which is BC, upon the hypotenuse AC. So A by A root 2, A and A will go cancelled and you will be left out with 1 by root 2. So sine 45 degree is 1 upon root 2. Cos 45 degree is adjacent side of angle 45 degree by hypotenuse. Adjacent side is AB, hypotenuse is AC. Again A gets cancelled, we get the ratio as 1 upon root 2. Tan 45 degree is opposite side by adjacent side, BC upon AB, they both are equal to A, so the ratio becomes 1. As I mentioned you can remember this SOHCAHTOA. Opposite by adjacent, adjacent by hypotenuse, opposite by hypotenuse. I made a mistake here. So SOH is opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent. When you know the three basic angles, we can find the remaining by taking the reciprocal. The reciprocal of sine 45 degree is cosecant 45 degree, we get root 2. Secant 45 degree is reciprocal of cos 45 degree, again root 2. Cot 45 degree is the reciprocal of tan 45 degree, which is 1. So these are the ratios obtained. Sine 45 is 1 upon root 2. Cos 45 is 1 upon root 2. Tan 45 is 1. Cot 45 is 1. These values are to be remembered. In solving question, we have to make use of sine 45 degree as 1 by root 2 and so on. This is about 45 degree. Let me take another right angle triangle in which the angles are 30 degree and 60 degree. I'll consider trigonometric ratios now of 30 degree and 60 degree. Let us calculate the trigonometric ratios of 30 degree and 60 degree. For that, let me consider an equilateral triangle. Since in equilateral triangle all the angles are equal to 60 degree, I'll consider a perpendicular. Let me draw a perpendicular AD from the vertex A to the side BC. What happens if perpendicular is drawn? This angle will be divided. In an equilateral triangle, you must remember the lines angular bisector, altitude and median, they all will be same in equilateral triangle only. So this particular AD will bisect BC. For that, I'll give an explanation. If you consider the triangle ABD and ACD, you can actually prove that they are similar as well as they are congruent to each other. What makes their congruency? If you consider these two angles, they are equal to 60 degree. We have drawn perpendicular. So AAS criteria, we get the triangles congruent to each other. When two angles are there, the remaining angles also can be considered, and this angle will be 30 degree. If you consider this angle and the side, it becomes ASA criteria. Therefore, the triangles are congruent to each other. Either it is AAS criteria or it is ASA criteria of congruency. When the triangles are congruent to each other, BD will become equal to BC Angle BAD will be equal to angle CAD. Both are CPCT. Now observe that in the right angle triangle, angle BAD is 30 degree, angle ABD is 60 degree. As you know, for finding the trigonometric ratios, we need to know the lengths of the sides of the triangle. Let us suppose that AB is, say, 2A units. If AB is 2A units, AC will be 2A units, BD becomes A units, and DC becomes A units. Let me once again consider. We had taken AB as 2A units, BD will be A units, DC will become A units, AC will become 2A units. We can find the length of this height or the altitude. H square will be equal to 2A whole square minus A square by Pythagoras theorem. So 4 times of A square minus A square will be 3 times of A square. So the hypotenuse will be a root 3 times A, or A times root 3. We are going to make use of this. The same thing I have explained here. BD is half of BC, which is A units. By using Pythagoras theorem, AD is found as A root 3 units. Now to define the trigonometric ratios, sin 30 degree is opposite by hypotenuse. BD is the opposite side with respect to 30 degree. So A by 2A becomes 1 by 2. Cos 30 degree is AD upon AB, which is A root 3 upon 2A. We get a root 3 by 2. Tan 30 degree is BD upon AD, which is A by A root 3. We get the ratio as 1 by root 3. Cosecant 30, secant 30, cot 30, they are the reciprocal of sine, cos and tan respectively. So we can find the other 3 ratios also. In the similar way, when 60 degree is considered, AD becomes the opposite side by hypotenuse is AB, AD by AB. We get sine 60 as root 3 by 2, cos 60 as 1 by 2, tan 60 as root 3. Cosecant 60 is a reciprocal of sine, we get 2 by root 3. Secant 60 is a reciprocal of cos, we get 2. Cot 60 is reciprocal of tan 60, it is 1 upon root 3. These values are again very important for you to remember. Let us move on further to define the trigonometric ratios with respect to 0 degree and 90 degree. Let us see what happens to the trigonometric ratio of angles. A, if we made smaller and smaller in the triangle ABC till the side becomes 0, angle becomes 0. As angle A gets smaller and smaller, the length of BC is going to be decreased. The point C gets closer and closer to the point B, and finally angle A becomes very close to 0 degree. It is explained through this figure here. When this angle is reduced, here you can see the angle is reduced, the point C slides down and it becomes smaller. When the angle is reduced further, the side is going to be reduced further. When the angle is made very close to 0, this point C, it overlaps with the point B, or this particular length BC will become equal to 0. Understood? If the angle is made very small to 0 degree, the side BC becomes equal to 0. If you look at the first figure here, AC is what? It's the hypotenuse. The length of the hypotenuse also will be decreased in the process. At the end, what we get is the hypotenuse and the adjacent side will become equal. When angle A is very close to 0 degrees, BC gets very close to 0, so the value of sine will be 0 upon AC, it becomes close to 0. When angle A is very close to 0 degree, AC is nearly same as AB. They are equal, AC and AB are equal. So the cos will be, cosine of the angle will be AB upon AC, it becomes close to 1. Understood? This will help us to show how we can define the values of sine, cos. When angle is 0 degree, sine 0 degree is 0, cos 0 degree is 1. When these two angles are known to us, we all have learned tan of an angle is sine of the same angle by cos of the same angle. We get 0 upon 1, which is equal to 0. And cot of the angle is 1 upon tan, it's a reciprocal. 1 by 0 is not defined. Why it is not defined? 1 by 0 is not defined. We all have learned division. Division was possible when divisor is a non-zero number. If 0 is there here, do we get any quotient? We won't get quotient. No quotient will be there. So the denominator should never be equal to 0. Secant of an angle is reciprocal of cos of the angle, which will be 1. Cosecant of the angle is again not defined. It is for the same reason no quotient is obtained. Now let us see what happens if the angle A, when it is made larger and larger till it becomes 90 degree. Look at this figure. As angle A gets larger and larger, angle A is getting larger and larger, this particular A will be slided to the right. When the angle is completely 90 degree, A and B will overlap. What does it mean? It means that the length of AB becomes equal to 0. What happens to the length of AC? It becomes equal to the length of BC. Nearly it is equal. As A gets larger and larger, angle C gets smaller and smaller. This angle C will be decreased. Therefore, in this case, AB goes on decreasing. A gets closer to the point B. Finally, angle A is very close to 90 degree. Angle C becomes very close to 0 degree. Angle C will become 0 degree and angle A will become 90 degree. The side AC almost coincides with the side BC. Now let us see the angles. When angle C is very close to 0 degree, angle A is close to 90 degree. AC becomes nearly equal to BC. In such cases, we have sine of 90 degree is opposite by hypotenuse, which are equal here. The length of AB and the length of BC and AC, they are equal, opposite by hypotenuse. It is something like this. If you remember the triangle, we had ABC. This was our angle. Opposite is BC upon AC. When AC and BC, they become very close, they coincide, the ratio becomes 1. Cos of the angle 90 degree is AB by AC. The length of AB becomes very close to 0. So 0 upon AC will become 0. Why don't you find the remaining trigonometric ratios with respect to 90 degree? What is tan of 90 degree? Tan of 90 degree is sine of 90 degree upon cos of 90 degree. This is 1 upon 0, not defined. Now we have the reciprocal relations. Cosecant of angle is cosecant 90 degree is 1 upon sine 90 degree, and it will be equal to 1 upon 1. The value is 1. Secant 90 degree is 1 upon cos 90 degree, which is 1 upon 0, which is not defined. Cotangent of 90 degree is 1 upon tan 90 degree, which will be 1 divided by 1 by 0, which becomes 0 by 1, which is 0. You need to remember these angles too. I have consolidated all the angles which we have found in a table. Look at this table. When angle A is 0 degree, with respect to 0 degree, sine 0 is 0, cos 0 is 1, tan 0 is 0, cosecant 0 is not defined, secant 0 is 1, cot 0 degree is not defined. Look at sine of the angle with respect to 30 degrees. Sine 30 is 1 by 2, cos 30 is root 3 by 2, tan 30 is 1 upon root 3, and so on. In most of the questions, these 30 degree, 45 degree, 60 degree are used for the maximum. So you need to remember all the angles, at least these 3 pairs, because the remaining pairs we can find it as a reciprocal. Again, to remember this particular table, I'll give a trick. It's a very simple trick. What you need to do is, you write the numbers right from 0 to 4. 0, 1, 2, 3 and 4. Divide by 4. You have to write the numbers till 4, then divide each number by 4, then take the square root. When we take the square root of 0 by 4, which is 0, when you take the square root of 1 upon 4, we get 1 by 2. This will be 1 by root 2. This becomes root 3 by 2, right? This becomes 1. These are with respect to 0 degree, 30 degrees, 45 degrees, 60 degrees and 90 degrees with respect to sine of the angles. Now to get the cos of the angle, write the same thing in a reverse order. Start from 1 written here, then root 3 by 2, then 1 by root 2, then 1 by 2, then 0. Now once the sine and the cos are known, we can divide them to get tan of the angle. Tan 0 degree is 0 by 1, 0 by 1 is 0. 1 by 2 divided by root 3 by 2 is 1 upon root 3. This will be 1. This becomes root 3. This is not defined. This is how we find the angles with respect to sine. Now if you want the angles with respect to cosecant, you have to take the reciprocal of this. 1 by 0 is not defined. I'll write as ND. This is with respect to cosecant of the angle. 0 degree is not defined. 1 by 2, its reciprocal is 2. 1 by root 2, the reciprocal is root 2. This reciprocal is 2 by root 3 and 1. These are with respect to cosecant. To get secant, we take the reciprocal of cos. 1, 2 by root 3, root 2, 2 and not defined. If you observe, they are the same thing written in a reverse order. Now write tan of the angle, which is reciprocal of cot of the angle, which is reciprocal of tan of the angles. So 1 by 0 is not defined. This will be 1 upon 1 by root 3 becomes only root 3. 1 by root 3, this becomes 0. This cot of 90 degree will be 0 by 1. 0 by 1 is absolutely defined. It is taken as 0. This is how you can remember this table in the examination. There are chances that you may forget the angles directly while substituting. What you can do is you can write in this way: divide by 4, take the square root, find sine of the angle, write the same thing in a reverse order to get the cos of the angle, then divide to get the tan of the angle, then take the reciprocal to get cosecant, secant and cot respectively. That's all for today's session. We shall solve the exercise questions of exercise 8.1 followed by the exercise 8.2 in the next session. Thank you.